Welcome to the Explainer. In the world of A/B testing, we're taught that precision is everything. But what if I told you that the most sensitive, most precise metric you have might actually be your weakest? Today, we're going to dig into some really fascinating, counterintuitive research that'll make you rethink what you know about statistical power. So let's just start with that provocative question right up front. We spend so much time and energy trying to make our metrics as precise as humanly possible. But what if that laser-focused metric is the wrong tool for making the big picture decisions that actually move the needle for your business? Okay, before we dive in too deep, let's do a quick refresher on our main character today, statistical power. Simply put, it's the chance that your experiment will actually see a real effect, assuming there is one to be found. You know, if there's treasure on an island, power is how likely your map is to actually lead you to the X marks the spot. You want high power because you don't want to leave gold in the ground. Now, for years, the way we've measured this sensitivity is with something called the minimum detectable effect, or MDE. This is the tiniest little change your test can reliably pick up on. And the conventional wisdom has always been, get that MDE as low as you possibly can. A lower MDE, we thought, means a more powerful metric. But as we're about to find out, that assumption is just, well, it's deeply flawed. It's really a classic right tool, wrong job problem. I mean, a microscope is an amazing piece of technology, perfect for seeing tiny little cells. But if you're trying to discover a new planet in our solar system, it's completely useless. In the exact same way, a super precise metric might be great at spotting tiny little wobbles, but it could be totally blind to the huge, game-changing impacts you're actually hoping to find.
All right, let's leave the analogies behind and look at a real-world example from the research that really makes this paradox pop. This is where it gets really interesting.
So let's meet our two contenders. In this corner, we've got metric A. It's the precision powerhouse. It has been engineered to have incredibly low variance, so it's super sensitive to the tiniest changes. And in the other corner, we have metric B. It's kind of the scrappy underdog. It's noisier, it's got higher variance, and it's just not as good at picking up on those really small effects. Now, if we were judging these two based on the traditional MDE approach, well, it wouldn't even be a contest. Metric A has a much lower minimum detectable effect, so according to the old playbook, it's the better choice. Case closed, right? I mean, it seems obvious. It's more precise. It's more sensitive. It's literally everything we've been told to aim for in a metric. It has to be the more powerful one. Doesn't it? Not even close. And this right here, this is the slide that flips the whole script. When the researchers calculated the actual real-world average power, the results were just jaw-dropping. The so-called noisier metric B is nearly 5 times more powerful than the precise one. So what on earth is going on here? This is the big mystery, the central paradox we need to unravel. How can the metric that's less sensitive, more variable, be so much more powerful? It just flies in the face of everything we thought we knew. Clearly, that standard MDE calculation is missing a huge piece of the puzzle. And the answer, as it turns out, lies in a hidden variable that our traditional power calculations just completely ignore. It's the secret ingredient that makes this whole thing make sense. And that secret ingredient is the distribution of true effect sizes. Here's the big mind shift. We have to stop focusing only on the precision of our measuring stick and start thinking about the actual size of the things we're trying to measure. It's not just about how well you can measure, it's also about what you're measuring. Let's go back to our analogy for a second. Think of metric A as a super-sensitive metal detector that's been fine-tuned to find tiny things, like paper clips. It's very precise, sure, but it's looking for small potatoes. Metric B, on the other hand, is like a big, powerful ground-penetrating radar designed to find massive buried treasure chests. It might miss the paper clips, but if you're trying to find treasure, which tool do you actually want? This slide really just lays it all out. Metric A, super precise, but it's measuring things that tend to have tiny effects. Metric B, a bit less precise, but it's capturing changes that have much larger impacts. So the huge insight here is that true power isn't just about precision. It's about the marriage between precision and the magnitude of the effect you're actually looking for. Okay, so we've identified the problem. The old way of just looking at MDE is broken. So, how do we fix it? Well, the research proposes 2 really clever new frameworks that give us a much more accurate way to figure out a metric's true power. All right, the first one for all you frequentists out there is called prior informed average power. Now, it sounds a little academic, but the idea is actually super intuitive. Instead of just picking one arbitrary MDE number, you look at a whole range of possible effect sizes based on your past experiments. Then you just average the power across all those likely scenarios. This gives you a way more realistic picture of how strong your metric is. Now, if you're more of a Bayesian thinker, there's another approach called Bayesian decision power. This one is even more focused on the bottom line. It directly answers the question that every stakeholder really cares about. What's the chance this experiment will give us a clear launch or don't launch decision? It connects statistical power directly to making a business decision.
So, now that we've got this new way of thinking about power, what does it actually mean for you day to day? Let's talk about how this shift in perspective can change how you design and run your experiments.
Look, if you only remember 3 things from this explainer, make it these. First, MDE is not the whole story. Second, the likely size of the effects is just as important as your measurement precision. And third, a noisier metric can absolutely be more powerful if it's better at capturing big, meaningful business impact.
And when you really start to embrace this mindset, it has this amazing ripple effect. You'll make smarter calls on how long to run your tests, how to allocate traffic, and, most importantly, you'll start picking the right metrics from the very beginning. You'll choose metrics that are truly powerful, not just the ones that look good on a spreadsheet. So, I'll leave you with this challenge. The next time you're planning an A/B test, I want you to pause and ask a different question. Instead of asking, what's our most precise metric? Ask, what's our most powerful metric for the kind of impact we're trying to create? The answer just might surprise you, and honestly, it could be the key to your next big win.